want to connect one use case to another use case, I connect those two use cases with the help of the dependency relationship. That too, it is not a normal dependency, it is a specialized dependency relationship, which is called to be as extend and include. Extend relationship and as well as include relationship. Extend is explained, or extend is mentioned as the target use case extends the behavior of the source. Target use case extends the behavior of the source. That means the final use case, whatever the final use case which we represent in the model, it extends its behavior to its source. I think you all know, I represented many examples with by using include and extend also. Include and extend relationships in our offline classes. For example, if you want to attend the exam and if you want to pass the exam, what is the source use case? The target is nothing but clearing the exam with good result. If you consider the target as the clearing the exam, the source can be attending college regularly or starting from your home or whatever it may be. Okay, if we extend the behavior, the target use case extends the behavior of the source. If we extend the source use case up to target, then I can say that an extend relationship has been established in between those two use cases. Next, include relationship. Source use case incorporates the behavior of another use case. If one use case embeds or inscribes another use case inside it, then I can say that an include relationship exists between those two use cases. So include and extend are represented by using a dependency relationships, then but they are considered to be as specialized dependencies. They are considered to be as specialized dependency relations. Next one, to model interactions. Interaction is the first thing which we discussed in behavioral things. The things are classified into four types: structural things, behavioral things, grouping things, and as well as annotational things. So interaction is the first thing which we have discussed in the behavioral things, which is in the conceptual model of the UML. So to model interactions, the symbol or the representation which we use for interaction is, I think, not I think, the interaction looks like this. So a solid line with a shaded triangle. A solid line with a shaded triangle. The advantage of using interaction in between two classifiers or two components or two tools is nothing but it helps to pass the messages from one component to another component. The advantage or the use of interaction in between two classifiers or two tools or two components is nothing but it is used to pass the information from one component to another component. We will discuss more on these interactions when we discuss about sequence diagrams, that is interaction diagrams. Mm, Interaction diagrams are classified into two types. They are sequence and collaboration. And I said that those two are considered as the isomorphic diagrams. The meaning of isomorphic is nothing but the conversion of one type into another type without any loss of information is considered as the process of isomorphism. That means we can convert the sequence diagram into collaboration diagram and collaboration diagram into sequence diagram without any loss of information. Okay. So, in order to model the interactions, three stereotypes are applied. The first stereotype is become. The first stereotype is become. What is the meaning of become is the target remains the same object as the source, but at different points of time. The target remains the same object as the source, but at different points of time. Target and source both acts as same thing. Okay, target and source acts as same thing. For example, Which example I can give here for you is generally what I can say is um, a lion and a lion cub. A lion and a lion cub. For example, lion cub is the target and lion is the source. Both are considered to be as the same lion only, right? That is the normal and general and a simple example which I want to give for you. Next, call. Source calls the target. Source calls the target. Obviously, we know. Previously, we have seen in this example. In order to calculate the source, we need to have the knowledge of target. In order to calculate the source or in order to get the source value, we need to have the target values first. Next, copy. Target is an exact copy of the source but independent in nature. Target is an exact copy of the source but independent in nature. The same example I can apply here. Target remains the same object as the source. If we divide, I think this is not applicable because we can calculate the source from target, but target from source is not, we won't get inappropriate. Because, for example, if I consider the Mark 1 as 100 and Mark 2 as 98 and Mark 3 as 99, 100 plus 99 plus 98, that means 297. Okay, the total is 297. For example, okay, Mark 1 is 100, Mark 2 is 99, and Mark 2 is 98. So 297. But from source, I can't calculate the target. That means I can assign 98 at the M1, 900 at M2, and 99 at M3. That means the values will be changed. So for this point, what I can give as an example is a target is an exact copy of the source, but independent in nature. Target and source are same, but both are different. Okay. Um, Male and female, both are humans, but they are independent in nature. Okay. One stereotype is applied in state machines. State machine, the symbol or the representation which we use in order to represent a state machine is a rounded rectangle. A rounded rectangle is used to represent the state machine. So the meaning of state machine is nothing but, for example, we get this state machine. For example, a previous state machine is there. A previous state machine is there. Of course, this should be in the form of a rounded rectangle. I have represented in the form of an ellipse. It should be a rounded rectangle. So with this, for example, consider this as the first state machine and second state machine. If we apply some action to the first state machine, we will get the second state machine. Okay, that is the meaning of state machine. On the Newton's third law, for each and every action there is an equal and opposite reaction, not Newton's third law. That means what I can say is, if we apply some action to the first event, then with the use of that action or the with the what I have to use, because of the action which I have applied to the first one, I got the second one. Okay, that is called as the state machine. We have the separate unit for this state machines as well, and so source sends the target event. Source sends the target event. That means the vice versa. Normally, target sends the source here, whereas in the concept of state machines, source sends the target. Next, generalization. The relationship between a general classifier and more specific classifier. In order to represent the relationship between a general classifier and the more specific classifier, we use generalizations relationship. So here the general classifier is considered as a super or parent class, and the more specific classifier is considered as a subclass or a child class or a leaf class. So UML specifies one stereotype and four constraints with respect to generalization relationships. So the one stereotype and four rules which we can assign with respect to generalization relationships are: the first and the only a single stereotype which we can apply for generalization is implementation stereotype. Child inherits the implementation of the superclass or parent. You all know about that. Child inherits the properties of the parent. That is called as implementing property or implementation property. That is considered as the stereotype with respect to generalization relationship. And the four constraints which are applicable to generalization are complete, incomplete, disjoint, and overlapping. If we see the first one, that is complete constraint, it indicates that all the children in the generalization are specified in the model. So when we can say a model is considered as a complete one, when we are discussing about the generalization relationship, first of all, we need to represent the parent class. First of all, we need to represent the parent class, and as well, after representing the parent class, we need to mention or we need to specify or we need to render all the child classes with respect to the parent class. We're not supposed to skip or we're not to supposed to skip or we're not to supposed to remove any child classes with respect to a particular parent class. That is called as complete constraint. Next, incomplete. The reverse to complete is nothing but incomplete. That means if you miss any child classes or leaf classes with respect to a particular parent or super or base class, then it is called incomplete constraint. Next, disjoint constraint. Objects of the parent may not have more than one children. Objects of the parent may not have more than one children. That means only a single child exists for a parent. That is considered as a disjoint constraint. If only one child exists for a parent, then it is considered as a disjoint constraint. Can anyone tell me what is the difference between a single inheritance and multiple inheritance? I want to know the difference between single inheritance and as well as multiple inheritance. You can type it in the chat box, or if you want to unmute yourself, and you can unmute yourself and you can speak out the difference between those two things. My question is, what is the difference between a single inheritance and multiple inheritance? Yes, please, I'm waiting for your response. What is the difference between a single inheritance and a multiple inheritance? If you know the concepts and if you know the all the terms and the basic terminology in OOAD, then this subject is considered to be as the easiest subject in your BTech. But if you won't know the single inheritance inherits single base class exactly, then what do you mean by multiple inheritance? When I can say a single inheritance is nothing but if a child consists of only one parent, it is considered as single inheritance. Multiple inheritance is one in which the derived class acquires two or more base classes. Super. Okay, both are correct. And Multiple inheritance is one in which the derived class acquires two or more base classes. Why two of you gave the same answer? Same answer. Not even a single word has been differed between both of you. That means you people asked each one of you, and you have copied the answer or what? Very. I know your name. What is your another other person name? Do you want me to name your roll number? Hello. I know the name of one person, but I don't know the name of the another person. K not K7. It's not you. K7. It's not you. Okay, okay. I think both of you have searched the answer at the same time, and you people have copied the answer at the same time again. Can I know your name? Nothing wrong in that. Just I'm asking. What's your name? Okay, exactly. Okay. So, single inheritance in the sense child consists of a single parent, and multiple inheritance in the sense a child consists of uh, more than one parent. So disjoint is nothing but object of the parent may not have more than one children. That means a single inheritance exists between the child and the parent here. Next, overlapping. It refers to disjoint. That means the parent can have many number of children. That means multiple inheritance exists between the child classes and as well as the subclasses. Next, associations. It is a structured relationship, comma, objects of one thing are connected to the objects of another thing. That means if we want to establish the mutual communication or one-way communication in between the objects in a particular mode, then we need to use or we need to go for association relationship. The association relationships are classified into how many types and what are they? Association relationships are how many types and what are they? And can you tell me, any one of you tell me the difference between those two things? I said that association relationship is used to establish the communication or to start the communication tools. Now, what are they? And differentiate between those two things. One thing I want to ask you, people, instead of teaching the class, that means instead of unmuting myself and instead of speaking, if I explain the entire thing through chat, do you feel it as good? I'll repeat my statement again. Instead of unmuting myself and instead of attaching my headphones, if I keep on chatting with you people, that means whatever the topics which I want to discuss, if I teach those topics in the form of textual manner instead of a vocal manner, do you feel it as good? It saves lot of energy for me, right? So if I ask any one of you unmute yourself, like kind of a thing, why can't you unmute yourself and why can't you speak out? I feel better if you unmute yourself instead of typing the answer in the chat box. How many types of associations exist and what are they, and differentiate between those two? Yes, I'm waiting for your response. Don't waste my time. Lakshman, can you speak? Lakshman, why? Oh, Mukul, Mukul,